Think about it. One human, alone, in a place where stepping outside means you are dead in 60 seconds, where the air is unbreathable, the nights drop to minus 125 degrees, and the nearest repairman is 225 million kilometers away. There is a common misconception that Mars is just a colder, quieter version of Earth, a plan B waiting for us to arrive. But the reality of the Martian surface is much closer to a horror movie than a new home. Despite these dangers, Elon Musk and SpaceX are pushing a timeline that puts humans on the red planet as early as the 2030s. The sheer momentum of the commercial space industry makes it feel inevitable, like we are just 1 or 2 more launches away from a permanent colony. But before we get swept up in the hype, we have to look at what the documented science actually says about human survival. Behind the slick PR campaigns, there is a fundamental conflict between our fragile biology and the mechanics of a planet that is actively trying to kill us. The danger doesn't start at landing. It starts the moment you leave Earth's orbit. For 9 months, astronauts are trapped in a tiny spacecraft, drifting through a vacuum. In zero gravity, the body begins to dismantle itself. Because there's no gravitational resistance, your bones lose density and your muscles begin to atrophy. Fluid shifts in the brain can also lead to permanent vision damage. The person who finally reaches Mars won't be a hero in peak physical condition. They will be a patient who has spent 9 months physically degrading. And all through that journey, invisible cosmic radiation is continuously penetrating the hull of the ship, damaging the crew's DNA with every passing hour. This is the reality of the transit. You arrive at the most hostile environment in our solar system in the weakest physical state of your life. Once you land, the environment is a lesson in atmospheric starvation. The air is 95% carbon dioxide and carries only 1% of the pressure we have on Earth. Temperatures are equally extreme. Even if you land at the equator, a manageable 20-degree day will crash to minus 125 degrees the moment the sun goes down. Then there are the dust storms. As these Hubble images show, these aren't just local events. They can swallow the entire planet for months, blocking out the sun completely. We've seen what this does to our best technology. In 2018, a global storm like this choked the solar panels of the Opportunity rover, ending a 15-year mission in a matter of days. But the most lethal threat is the radiation. Earth has a magnetic field and a thick atmosphere to deflect and absorb harmful rays. Mars has practically neither. NASA's Curiosity rover measured surface radiation at 17 times the level of Earth. A year on the surface provides enough exposure to cause direct DNA damage, trigger memory loss, and measurable cognitive decline. Survival on Mars isn't just a matter of keeping the lights on. It's a constant, losing battle against the cellular destruction of the brain and body. Because the surface is so radioactive, a long-term habitat would likely have to be built underground, burying the crew beneath meters of Martian soil just to keep their DNA intact. Then there is the oxygen. This is MOXIE, an experiment on the Perseverance rover that extracted oxygen from the Martian atmosphere. While MOXIE proved the chemistry works, scaling this up to support humans is a massive challenge. If the machines stop, the breathing stops. Even food requires a perfect closed-loop system. You have to grow crops in dead, irradiated soil within a heavily controlled environment, where one leak or system failure means total starvation. This is a zero-margin scenario. On Mars, a single mechanical error or a localized failure isn't a setback. It's a death sentence. We have already seen the corporate deadlines slip. The 2024 targets have passed, and the 2030s are looking increasingly optimistic because our life support technology simply isn't ready. If something goes wrong, there is no rescue. Due to the distance, even a radio signal takes up to 24 minutes to reach Earth. By the time we hear their call for help, it will already be too late. We must ask if it is ethically responsible to send someone into a documented death trap, driven by the pressure of PR cycles and billionaire egos. Our resources on Earth are finite, and the survival of our species may eventually require us to live on other worlds. But that transition only counts as progress if we can actually protect the people we send. The first person to stand on Mars will be the ultimate test of human resilience, looking back at a home billions of kilometers away. We owe it to them to win the battle against biology and radiation here before we ask them to face it there.